Hi everyone, and welcome to this section in which we're going to introduce ourselves to DevSecOps ecosystem. So, as everything into the IT world, the DevSecOps requires architectural foundation. So, in this section, we will learn how to compose a reference architecture for the DevSecOps, and there's some practices to design the pipelines with the DevSecOps. We will also discuss the best DevSecOps practices for the major public cloud providers such as AWS, Azure, and Google Cloud. So, in the previous section, we were discussing the principles of the DevOps, and so we concluded that security should be at the heart of every setup in the development lifecycle, from the moment where the code is pulled from the repository to the actual code being committed and pushed to the production. So the DevSecOps consists of three main layers. The first one is the culture, and this is not a technical layer, but it is quite often forgotten that DevOps is much more than applying tools and creating CI/CD pipelines. Obviously, the same applies for the DevSecOps. Within the DevSecOps, every team member feels responsible for security and acts accordingly, taking ownership of it. This doesn't mean that the security specialists have become obsolete though. It's good practice to have security engineer or professional in your team, sometimes referred as a security champion. This person should lead out the processes in the team for applying security standards and policies to ensure compliance. The next layer is the security by design. So the security is embedded at every layer of the system. This typically means that the enterprise has a detailed architecture that covers every aspect of security and enforcing security postures into systems, such as authentication, authorization, confidentiality, data integrity, and more. Software developers do not need to think of security every time they design and build new applications or features. And the final layer is the automation, because in DevOps we want to automate as much as possible. And the same accounts for the DevSecOps, because this also includes security. So by automating the security, we can easily prevent human error, and we can create automation tools to scan for possible vulnerabilities or non-compliant components such as unlicensed code. Automation also implies automated audits and collection of evidence in case of attack. So the automation process makes sure that security metrics are collected and sent back for feedback in the DevSecOps practice. For example, when you scan vulnerability in the code, an evidence from that scan will be collected and will be sent for feedback. So to manage those three layers, the DevSecOps relies on four main components, and those are harnessing responsibilities, application security, cloud platform security, and vulnerability assessments and testing. And so the DevSecOps should not be mixed with the security as a service. The security as a service can be compliant with the DevSecOps practice, but the concept of the security as a service is mainly about shifting security as responsibility to a service provider. This is a sourcing model that allows enterprises to get cybersecurity delivered from a service provider on subscription base. There are good reasons for implementing the security as a service, and one of them is that a provider is responsible for all security updates based on the latest insights. Enterprises can define security level agreements for incident response times and the timely application of security practices. So, before we discuss the reference architecture of the DevSecOps, we need to understand what the role of the DevOps is and how the security fits to it. So, DevOps is about the software development lifecycle. An important note is that we have to make sure that we know the fact that the developers increasingly use open source tools. This makes sense since provides great flexibility when developing new code. Open source is community driven, so developers can contribute to each other's code and speed up the process. Projects can be shared at open source platforms such as Git and GitHub repositories, but they can also be shared internally within the enterprises. So the inner source type projects are a good example of projects that are held internally. So inner source uses open source best practices for software development within the boundaries of the organization. In fact, we need security from the start of the DevOps process. In practice, this means that we start scanning for security issues from the moment the code is put from the repositories. The repositories are part of the software development lifecycle as well, so they should be protected from unauthorized access. And so this calls for role-based access, and identity and access management are quite important for the repositories. They're called RBAC and IAM. So you should keep in mind that we can create reference architecture for DevSecOps within those four components. The first one is a repository access within the role-based access control, the static application security testing, which will detect errors in the source code, the software composition analysis, which will detect dependencies in the source code, and finally the dynamic security testing, which will dynamically scan the code every single time. Those components are embedded into the DevSecOps pipeline and are quite important. So that's it. Thank you very much for watching, guys, this video, and in the next one we will talk about how we can compose the DevSecOps pipeline. Thanks for watching.